Well, at its heart, forensic science is all about analyzing evidence, right? So we're talking about really carefully studying different types of evidence to figure out what happened at a crime scene.
Like, so it's not just, dusting for fingerprints or something like
No,
that.
no, it's way more than that.
Right.
We're talking about analyzing everything from fluids, solids, gases, anything that could possibly hold a clue.
Wow. So they really do look at everything, huh?
Absolutely. Every little detail matters.
Now, the source material mentions something called offending masses,
Oh,
which
yeah.
sounds kind of intimidating.
Yeah, it does sound a little bit scary, doesn't it? But it's actually not as dramatic as it sounds.
Okay.
Offending masses basically just refers to any material that could be related to a crime.
So this could be anything, really.
Yeah, exactly. It could be a speck of dirt, a strand of hair, a tiny drop of blood, even a trace of perfume.
Wow. So they really are looking for anything and everything.
Exactly, and that's why it's so important to be meticulous when collecting and analyzing evidence.
Now, one phrase that really stood out to me was beady eyes from robotics.
Oh yeah, that one caught my eye too.
It sounds so futuristic.
It does, doesn't it?
What is that all about?
Well, that imagery really highlights the role of technology in forensic science.
Okay.
We're talking about really advanced analytical techniques that help us identify unknown substances.
So, like, what kind of techniques?
Well, two of the most important ones are colorimetry and spectrometry.
Okay, those sound pretty complex.
They are, but the basic idea is actually pretty simple.
Okay.
You shine a light through a substance and observe how that light interacts with it.
Okay.
And by analyzing the way the light changes, we can actually identify what the substance is made of.
So, light can tell us what something is made of.
That's exactly.
Okay.
It's pretty amazing, right?
That is pretty amazing. Now, what about this spraying mists onto burning flames?
Ah, yes, that one.
That sounds like something straight out of a movie.
It does sound pretty dramatic, doesn't it?
Are they literally setting things on fire?
Well, not exactly. It's a technique called atomic emission spectroscopy,
Okay.
and it involves heating a sample to a very high temperature, which causes the atoms in the sample to emit light.
So they are using fire.
Well, yes, but in a very controlled and scientific way.
Okay, but how does that help them figure out what the sample is?
Well, each element emits light at a very specific wavelength.
Oh,
So by analyzing the light that's emitted, we can identify the elements that are present in the sample.
so it's kind of like each element has its own unique light signature.
Exactly like a...
Now, the source material also mentions something called mass spectral position.
Right.
What is that all about?
So that refers to another technique called mass spectrometry.
Okay.
And this technique separates and identifies molecules based on their mass-to-charge ratio.
Okay, so it's another way to create a unique fingerprint of a substance.
Exactly.
What other methods do forensic scientists use to analyze evidence?
Well, there's a whole arsenal of techniques at their disposal,
Okay.
but one that's particularly interesting is called chromatography.
Chromatography. Okay, I've heard of that, but I don't really know what it is.
So chromatography is a way to separate the components of a mixture.
Okay.
And the source material describes it as repeated alternate residence on beads between liquid or solid phase.
That sounds complicated.
It is a little bit complicated, but the basic idea is actually quite simple.
Okay, how does it work?
So imagine you have a track made of tiny beads, and you introduce a mixture of molecules to the track.
Okay.
Then you flow a liquid or gas through the track, and different molecules will interact with the beads and the flowing substance to varying degrees,
Okay.
causing them to separate at different rates.
So it's like a race between different molecules.
Exactly. And by analyzing how quickly different molecules move through the track, we can identify what they are.
That's really cool. Now, what about this phrase, gels and vertical wells and high tension current?
Ah, yes. That's gel electrophoresis.
Gel electrophoresis. Okay, that sounds like something out of a science fiction movie.
It does sound pretty high-tech, doesn't it?
So what is it exactly?
Well, gel electrophoresis is a technique for separating molecules based on their size and charge.
Okay, and how does that help in forensic science?
Well, it's incredibly useful for analyzing DNA.
Oh, DNA, how so?
Well, DNA is a long-charged molecule, and it's unique to each individual.
Okay.
DNA profiling is like a game changer.
How so?
Well, for one thing, it's insanely accurate,
Okay.
and they can use it to link a suspect to a crime scene, like even years later.
Oh.
And sometimes it can actually prove someone innocent.
Really? That's amazing.
Right. And you know what else is really cool? The poem even mentions mitochondrial DNA.
Mitochondrial DNA, what's that?
So it's DNA that's passed down from your mother.
Oh, interesting.
And that's super useful when you're analyzing like really old samples
Okay.
or samples that have been degraded somehow. where regular DNA might not be there anymore.
Wow, I had no idea.
Yeah, it's pretty incredible how much info they can get from even the tiniest little piece of evidence.
Totally. But you know what? The poem makes it clear that forensic science isn't all about DNA.
Oh yeah, definitely not. There's a whole bunch of other techniques.
Right. Like what?
Well, it mentions microscope work, like looking at fibers and hair and stuff.
Okay.
And then there's tool mark analysis, where they try to figure out what tool was used at a crime scene.
Oh, right. Like if they find a screwdriver or something.
Exactly. And they can even uncover hidden messages, like with electrostatic writing.
Wow. It's like they have a whole arsenal of tools.
They really do.
So tell me more about tool mark analysis. That sounds super interesting.
Okay, so basically every tool, no matter what it is,
Yeah.
it leaves unique marks behind.
Oh, I see.
So let's say they find a bullet at a crime scene, right?
Mm.
Forensic scientists can look at the marks on that bullet and compare them to a suspect's gun. Oh, wow. So they can actually link the bullet to the gun.
Exactly. Or they can do the same thing with a lock, if it's been forced open.
That's amazing.
It's like giving every object its own fingerprint.
So cool. But you know what really struck me about the poem? It's not just about the science, it's about the people behind it all.
Oh, definitely. Like the analysts and investigators.
Yeah. It even calls them out, saying they conceived a myriad of methods and rouses to counter society's constant abuses.
Wow. That's powerful.
It really is. It reminds us that it's not just about fancy techniques, it's about the human element.
Totally. They're the ones putting all the pieces together.
Right. So what do you think makes a good forensic scientist then?
Well, they definitely have to be good at problem solving,
Yeah.
Like detectives in the lab.
Love that.
They have to interpret the evidence, figure out what it all means.
And then explain it all.
Right.
Right.
Often in court, too. So they have to be good communicators.
It's a lot of pressure.
It is. But they're basically helping to solve crimes and bring justice. That's so important.
Absolutely.
Wow. So